Hello, welcome back to Learn Physics. In today's topic, we are continuing with our laws of motion. Okay, in that the rest of the portion is friction. What is meant by friction? So in small class onwards you are studying about the friction, maybe from 6th onwards you are studying friction, isn't it? Tell me what is meant by friction? Yes, it is the opposing force when two objects are in motion, or when one object slides over another, or one object rests over another. What is the force which is affecting between them? That is called a friction. Okay, it is the opposing force. Opposing force, that is correct. So if we are applying the force in this direction, frictional force will be acting in the opposite direction. Okay, that is friction. Friction mainly divides into it's static friction. What is meant by static friction? Static means rest. If the object is at rest, what is the friction acting between them? That is called a static friction. See here, if the object is at rest, so but at the surface of contact it has a frictional force. Because of that only it's not moving. Okay, if I am giving an external force against this frictional force, and if that force is able to move, is overcoming the frictional force, it will start moving, isn't it? An object is here, it has friction, that's why because of that opposing force it can't move. If I am giving a force to that object, if that force is enough to overcome the frictional force, then the object will start moving, isn't it? So till that time it is at rest position. So friction acting on the object when it is at rest, that is called the static friction. Okay, next is kinetic friction. When one object moves over the other, the friction, one object moves over the other, movement due to movement. At the time of movement, what is the frictional force acting on the object? If the object is moving also, it will be having frictional force, isn't it? So that force is called as kinetic friction. Okay, that friction is known as kinetic friction. Now third one is rolling friction. Rolling friction means when one object rolls over the another. When one object rolls over another, the friction acting between the two objects are called a rolling friction. Okay, now we are going to study about one more friction is there, limiting friction. What is meant by this limiting friction? Limiting friction is when, see, I am applying a force on one object. See, this is an object, I am applying a force. It's not moving. Okay, I am applying little bit more force. The force which is it is at the wedge of static friction and kinetic friction. When it is about to move, at that time it is at the wedge of static friction and kinetic friction. That means it is when it is about to move, the frictional force which is acting is called as limiting friction. Okay, so static friction means when the object is at rest. Kinetic friction means when the object is under motion. So limiting friction means when it is at the wedge of the static friction and kinetic friction, then we can say it is called a limiting friction. Okay, next we are going to study about the laws of friction. Laws of friction. First we are going to study about the laws of kinetic friction. Okay, in the case of laws of kinetic friction, first one is kinetic frictional force is directly proportional to the normal reactional force. What is the meaning of that? See, if this object is under motion, it will be having a force acting downwards mg. It will be having a reactional force also. So the kinetic frictional force is this normal reaction. If I am representing it as N, Fk is proportional to this normal reactional force. Okay, and second one is kinetic friction is independent of the area. Independent of area, and third one, it is independent of speed also. Okay, kinetic friction is independent of the area. It is not depending on the area of surfaces in contact, and it is independent of the speed. Okay, that is kinetic frictional force, laws of kinetic friction. Okay, next we are going to study about the laws of limiting friction. What are the laws of limiting friction? First one is limiting frictional force is directly proportional to the normal reaction. This also depends on the normal reactional force. And second one is it is independent of the area. That also same, independent of area. Then it depends on the depends on what? It depends on the nature of the surface in contact. Nature of the surface in contact. Nature of surface which is in contact. This is laws of limiting friction. So frictional force is directly proportional to the normal reactional force. Okay, if it is a static friction or if it is limiting for this kinetic friction, that will be the case. Always the frictional force is proportional to the normal reactional force. Okay, so if Fk is proportional to N, to change the proportionality sign, we can multiply with a constant called mu k. So mu k into N. What is this mu k? Mu k is called as coefficient of kinetic friction. Mu k is called as the coefficient of kinetic friction. Mu k equals ratio of kinetic frictional force to the normal reaction. Or in the case of static friction or limiting friction also, this one we can write it as F is equal to mu s into N. In the case of static friction, mu s into N. What is mu s? It is the coefficient of static friction. Okay, so mu s is equal to Fs divided by N. It is the ratio of static frictional force to the normal reactional force. Okay, clear? So what is meant by, what are the laws of friction and all? Clear for you? Now we are going to find out the angle of friction and angle of repose. Okay. Next is angle of friction. What is meant by angle of friction? Suppose an object is here on the surface. Okay, it will be having mg downwards and it will be having reactional force and it will be having a frictional force in the opposite direction. So, reactional force, it's a vector like this, and frictional force a vector like this. What is the resultant of this frictional force and the normal reactional force, or we can write it as N because we were writing it N here, right? So what will be the resultant? Complete the parallelogram, you will be getting the resultant force like this. Okay, the resultant of this two forces, this is the resultant force, okay, and the normal reaction, angle between these two, that is known as angle of friction. So here if OAB, if I am considering this one, so the resultant of the frictional force and the normal reaction, the resultant of this limiting friction and the normal reaction makes with the reactional force. That angle is known as angle of friction. So I am considering the triangle OAB, so OBA. It's a right angle triangle. So what will be tan theta? Tan theta equals opposite side divided by adjacent side. Adjacent side is OB. What is opposite side AB here? It is equal to F, frictional force. What is OB? Normal reaction. F by N. What is F by N? Limiting frictional force divided by N is equal to mu S. Mu, coefficient of friction. So mu equals tan theta. This is known as angle of friction. Tan theta, if you are finding out, you will be getting mu. So if they are asked to find out theta, you can find out mu equals tan theta using this equation. Okay. Next is angle of repose. Angle of repose means a horizontal surface is here. Okay, the object is not moving. Okay, the angle when at a particular angle where it starts to slide over through the inclination. So from the horizontal, how much inclination is required? From the horizontal, how much inclination is required for the object to slide over the other? That is known as angle of repose. So if this is the horizontal surface, this much is the angle if it requires, then this angle alpha is known as angle of repose. Okay, so how we can find out this angle of repose? I am considering an object here. So this is mg acting downwards. Reactional force will be perpendicular to the surface. So R is like this, and we can consider this mg here. This will be the frictional force, isn't it? So friction is acting in this direction, and so here if R is like this is R cos theta, cos alpha, and this is R sin alpha, isn't it? So Fe is balanced by R sin alpha, and mg is balanced by R cos alpha, isn't it? So we can find out that F by mg, that is equal to tan alpha. What is this mg? That is the normal reactional force. N is equal to tan theta or tan alpha. Okay, so this will be the mu. Again it is getting it as mu. Mu is the tan alpha. Like that also we can find out the angle of repose. So you understood how we are finding out the angle of repose and angle of friction. Angle of friction means resultant of the frictional force and normal reaction makes with the normal reaction. That is called angle of friction. Angle of repose means minimum angle which is required from the horizontal for the object to move through this inclination. That is known as angle of repose. Clear? Next is motion of a car on a leveled road while it is taking a circular path. Okay, when the car is taking a circular path and it is taking a circular path, the road is a leveled road. If it is a leveled road, and leveled road means see no angle is there, only everything is straight. Okay, leveling. If you are using the leveling this instrument, it will be same. Okay, it's a leveled road. Okay, that is motion of a car on a leveled road when it is taking a circular path. Okay, so this is the leveled road and a car is here and it is going to take a circular path. Okay, this car is going to take a circular path like this. Okay, tell me what are the forces which is acting on it. So mg is acting downwards. Normal is reactional force. Anyway, normal reactional force is acting in the opposite direction, and then while it is taking a circular path like this, a friction will be acting in this direction. And it is taking a circular path. If we are thinking in that way, frictional force is acting in this direction, then why this car is not moving in this direction? An additional frictional force is acting in the opposite direction, right? So why it is not moving in that direction? While taking a circular path, centripetal force is acting towards the center of the circular path. Okay, so this frictional force is opposed with the centripetal force. Okay, what is the value of centripetal force? We learned about the centripetal acceleration, isn't it? What is centripetal acceleration? V square by R. So force equals m into a. So it will be mv square by r. So in this case, what are the total forces acting on the object? mg is acting downwards, normal reaction is acting in this direction, and forces, this is frictional force, and this mv square by r is acting in this direction. Okay, so if we are writing in this So horizontal and vertical forces N minus mg. N is taking as positive, so mg will be taking as negative. That will be equal to 0. Here frictional forces balanced with the mv square by r. So if we are considering the static friction, limiting friction and kinetic friction we learned. Fk is proportional to mu k into n we learned, and static friction we didn't learn. Static frictional force will be less than or equal to mu s into n. Okay, so static friction will be when Fs is equal to mu s into n, there what is happening? Limiting friction starts. Okay, till less than that one, what will be present? Static friction is present. When Fs is equal to mu s into n, limiting friction is present. So maximum static frictional force which can act will be equal to mu s into n. So we are getting as F is balanced with the mv square by r, isn't it? So what is the value of F? Mu s into n, that is equal to mv square by r. So what is this n? Normal reaction is equal to mg. From here we can write it as n equals mg. Therefore, mu s into mg will be equal to mv square by r. So m and m will get cancelled. What will be the velocity of the car at that time? V square equals mu s into rg. So velocity of the car will be root of mu s into rg. This will be the maximum velocity the car can take when it is taking a circular path, and if the car is on a leveled road. So it depends on which and all factors? Friction, static friction, and it is the radius of the circular path. We know, see, while we are taking a circular path in a leveled road, always they will take a big circle, isn't it? Those who are driving, they will be knowing. If you are taking a big circle, the chances of skidding is less over there, isn't it? So that is why, see, while going for a driving test also, always the our masters will be saying like that, isn't it? You please take a big circle. Big circle while you are taking, what will happen? Yes, the velocity, if it is increases also, we won't skid and fall. Okay, so V is equal to root of mu s into rg. Clear? So this is the maximum velocity. So less than this also it's okay. If we are taking less than this, that static friction will be affecting over there. So static frictional force maximum will be equal to mv square by r. Okay, clear this one? Next we are going to find out what will be the velocity of the car while it is taking a circular path on a banked road. Okay. Next is motion of a car on a banked road when it is taking a circular path. First we should understand what is meant by a banked road. What is meant by a banked road? See, while you are going through the road, you can understand, see, while taking a turn, if a turn is there, this is one end of the road and this is another end of the road. So while you are observing the right side to the left side, you can see it will be slightly, yes, a slight slope will be like this. This will be while only at the position where we are taking a turn. Okay, so in your say in front of your gate also, in your school gate or your gate also, we can see there a slight, see, while we are taking a turn like this, or we are entering to a mall or any one of the entrance, at the point of entrance while we are taking the circular turn, you should not see the straight road like this. You should see right end of the road to the left end or left end to the right end. A slope will be there. That is called as banked road. Okay, so you understood what is meant by a banked road. So now we are going to find out what will be the motion of a car on a banked road when it is taking a circular path. Okay, so banked road means, I told you, a slope is there. Okay, let theta is the slope. Car is here. What are the forces acting on here? mg will be acting downwards, reactional force will be acting like this, frictional force will be acting in this direction. Okay, we are taking a circular path like this. Okay, this is the position and we are going to take a circular path. So mv square by r will be acting in this direction. So what are the forces acting in this point? Okay, so I am considering this as the car. mg is acting downwards. R is not exactly downwards. It is normal to the surface, isn't it? So R is like this. And frictional force also inclined. It's not straight. Level the road means it will be straight. Here it is not straight. But mv square by r is straight. Tell me how we can see reactional force and frictional force. We should divide it into its components. So while I am dividing it into components, this is theta. Near to theta it will be cos component. R cos theta. Opposite to that it will be sine component. R sine theta. And if this is theta, what will be this one? F cos theta. And this will be F sine theta. Now we can consider the horizontal as well as vertical lines. So first I am considering the vertical lines. Tell me what are the vertical lines? mg plus f sine theta is balanced with the r cos theta, isn't it? So mg plus f sine theta equals r cos theta. Next, here horizontal line I am considering. R sine theta is there, f cos theta is there. These two will be balanced with the mv square by r. So r sine theta plus f cos theta will be equal to mv square by r. Write down r sine theta plus f cos theta will be equal to mv square by r. Okay, now we know F is equal to mu s into N, isn't it? Maximum force. So substituting F as mu s into N, here also we took it as R, isn't it? So mu s into R we can take. Fs is equal to mu s into R. So mg plus mu s into R sine theta equals R cos theta. And here while we are, so from here I can write down one equation for R. See mg, what is this mg? Mg is equal mg plus mg equals R cos theta minus mu s into R sin theta. So what is R cos theta minus R is common, mu s sin theta. So we can write R as equal to mg divided by cos theta minus mu s sin theta. Okay, so this much you understood. So here from this diagram, see this diagram you should understand very clearly. mg is acting exactly downwards. R will be perpendicular to the surface of the object. So it is acting like this. So it is at an angle theta. Since it is making an angle S, angle of repose is theta over here. So F cos theta plus R sin theta is balanced with mv square by R, and F sin theta plus mg is balanced with the R cos theta. So here we are getting two equations based on this one. Next, what we did, instead of F we can substitute mu s into R. From the first equation we wrote it like this and we got an equation for R. Now what we are going to do, now we are going to substitute R in this equation and we are going to find out the value of V. Shall we do that? Now equation 2 equals R sin theta plus, instead of F what we can write, mu s into R cos theta equals mv square by R. Okay, so R I am taking it as common. So R into sin theta plus mu s cos theta equals mv square by R. Okay, instead of r I am substituting this value, mg divided by cos theta minus mu s sin theta equals sin theta plus mu s cos theta equals mv square by r. So m is here, m is here. So I am taking this r this side, rg into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta equals v square. So what will be v? Square root of this one. I am doing one approximation here. Now I am going to divide with the cos theta in numerator and denominator. So I can write it as rg into sin theta by cos theta, tan theta. Cos theta divided by cos theta 1, so mu s will be existing, divided by cos theta 1 minus sin theta divided by cos theta tan theta equals v square, isn't it? Equals v square. So what will be v? Root of rg into mu s plus tan theta divided by 1 minus tan theta. Okay, here if I am considering mu s as equal to 0, what will be the value? So this will be the if. Here I can write if mu s equals 0, what will happen? See, this term will be equal to 0 and this term will be equal to 0. What will be existing? Rg and tan theta will be existing. Therefore, v equals root of Rg tan theta. This is the maximum velocity that we can obtain at the point if we are taking a circular path. Okay, clear? So, this is an important derivation. So all these derivations and laws of friction, angle of repose, angle of friction, all those things study nicely. And if you like this channel, please don't forget to subscribe. Okay, thank you for watching. Bye.